Let's start by looking at traditional safety engineering. The heart and soul of safety engineering is looking for hazards and risks and mitigating them. You typically do some sort of hazard and risk analysis for a conventional system. You list all the applicable hazards. Well, what could go wrong in a car? Well, you could have a battery fire. You could lose control of steering. You could have a system where the cameras fail or the LiDARs fail, or there could be an unexpected object in the road. There's a long list of hazards of things that can go wrong that you need to deal with if you want to be safe. You characterize the resultant risk of each hazard, and you make sure that any hazard that is too risky is mitigated. You update the design, you limit the operational design domain of the system so it just doesn't operate in areas that you cannot control the hazards adequately, and so on. And you keep iterating. You find a hazard, you mitigate it, you find a hazard and mitigate it until the overall risk presented by the design is acceptable. And at that point, it's time to deploy. With conventional safety, you're done. If you know all the hazards and you mitigate them all, that's it. You're safe. Time to go, at least in a theoretically perfect world. There are many different techniques you can use to create this hazard list. You typically start with lessons learned from previous projects, although if it's a novel project, you may not have much on that. Use industry standards, and there are structured brainstorming and analysis techniques, failure mode and effect analysis, fault trees, hazard and operational analysis called HAZOP. Bring your own favorite approach. There are many different approaches. In this talk, we're not going to get deeply into them, but suffice it to say there are structured ways that safety engineers have been working on for decades to try and find all the hazards so that you know what needs to be mitigated and mitigation techniques to do that. The presumption here with traditional safety engineering is that all hazards have been identified and covered before deployment. And along with that, that only works if you have a fully characterized operating environment. For industrial controls and things that happen inside a car, that might well be a completely reasonable assumption. But as soon as you get into detecting objects and events in the external world, the assumption that you actually understand the operating environment 100% becomes highly questionable.